Okay, in this question, we're looking for the rate law. We have our chemical equation here, but coefficients don't tell us anything about the rate law. We have to use experimental data, which is why we were given this table here. So we're going to use the experimental table. We're going to identify the order for first B using the first two lines where A is held constant. And then we'll look at A, which is a little trickier. We're going to look at lines 1 and 3 where A triples, but B also doubles. So that's going to impact the rate. So we got to identify what's going on, what impact does B have, and then we can look at the impact of A. But in order to do that, we first have to identify the order of B. So we're going to start with B here. And so we'll look at lines 1 and 2. And what we see for lines 1 and 2 is the rate goes from 0.85 to 2.55, which if we divide that, we get tripling of the rate. We now look at the concentration of B, and we have 0.30 over 0.10, and that's 3. So we see tripling the concentration of B raised to what power gives a tripling of the rate. And so that is a 1. So B is first order, which leaves us with these two possibilities. Now we got to identify A. What is the order of A? So this is where it gets a little bit tricky. So we're going to use lines 1 and 3. What we see is we have both concentrations changing, but we now know the order of B, so we know the impact of B. So if we go from 0.1 to 0.2, if we had held A constant, what we see is, right, 2 to the first power equals 2, the rate should double. And so that 0.850 times 2 would be 1.700. So this starting rate, so we could actually modify this first line and say, okay, this is, if this was 0.22, this would be 1.700. Now we're comparing a B not changing with A changing with our new rate. So now let's look at it as A. The concentration of A goes from 3.75 from an initial 1.25, which is a tripling of the rate. I always like to put the bigger number on top. And then the rate, 5.10 from what would be a 1.700, and that is a 3. So A equals what? So if we put a 3 in there, we raise it to the first power and we get a tripling of the rate. So they're both first order. So A is first order. And so what we are left with is C. Remember, 0 order means there's no impact. So you triple, you double, you triple, you quadruple the concentration of something, the rate would not change. First order means if you double it, the rate doubles. If you triple it, the rate triples. If you quadruple it, the rate quadruples. If you raise it by 2.5, the rate goes up by 2.5. And then second order means you're raising it to the second power. So if you double the rate, or sorry, you double the concentration, the rate goes up by 4. If you triple the concentration, the rate goes up by 9. If you increase the concentration by 2.4, the rate goes up by about 5, 2.4 squared. It's like 5.1, I think. So pay attention to that. And then this is a little bit tricky where you got to say, okay, how can I manipulate this line, knowing what I know about B, to have a good comparison with this line?